I'm Elissa.
I'm Gladys.
And we're here at Snake House Studios with Sound Museum Collective, here to show you how to build the stereo FM receiver module DIY kit. So let's get started.
Hey everyone, we're going to go over the components first. You always want to make sure you have everything that you need before you get started. So here we've got two resistors. One's a 30K. Then you will have inductors. Inductors usually look like coils, but right now they look like bigger resistors. You have your headphone jack or speaker jack, depending which cable you're using. The little baby chip there. Some capacitors. A crystal. The buttons. Your battery portal here. And when you open your kit, you may notice you're missing a piece. It's probably stuck somewhere within your battery portal there. And some zip ties to keep it all together at the end. Then you have your most important piece, which is the PCB board. It's the front, and here is the back. Some of the things you'll need for this project is tape. Tape will be to secure the chip onto the board. We want to make sure that we're not touching it as we solder due to the static. And it's recommended to wear rings or any sort of metal bracelet to help with the grounding. Wire cutters, it will help for a nice neat job. Your solder over here. Soldering iron, be very careful, it's very hot. And a wet sponge to clean off as you progress your work. We're going to start this project with the chip, which is probably the hardest part. Do not be discouraged though. It takes a lot of patience, and as we mentioned earlier, we don't want to touch it because of any static, so we're going to tape it right there.
How do you know the orientation?
I was just getting to that. Good question. We want their circle, see a circle at the top of the chip, should align with the U on the actual board. So once we've aligned it there with the tape, we'll go ahead and solder one side very carefully. Take the tape off and it will be on the board to do the other side. We've noticed that doing the other components, you won't have a lot of space. That's why we're starting with the chip here. And our patience is much longer right now in the beginning. So go ahead and take your solder and take your time. This is going to be great. We're going to lightly get some solder. Oh. There we go, one's on. And don't worry about the white stuff around there. You do want to be careful to not leave your solder on there for too long. The chip may fry. There we go. See the little trick? We'll put our solder down.
So if you look, these two legs at the very end are touching just a little bit. That's something we call a jumper. That should be okay. But for the most part, what you want to do, and even though it's quite difficult, you want to make sure that each individual point doesn't touch, because what it will do is create a bridge, and that buildup of solder ends up creating a lot of resistance and backs up the electricity, and it can cause your batteries to get hot. So this should be okay if you got just a little bit like this, but if you have a lot of excess solder that's making all the points connect, that's when you're going to start running into problems. I'll figure it out.
Now we've moved on to the other side. Took the piece of tape off. Beautiful. It's okay to get a little piece on and then move back. Looking good. Thank goodness for tinning.
So next we're going to do our capacitors, which these little ones are ceramic capacitors, and we don't have a schematic for this particular video, but capacitors, the symbol for them is like this, and it's because a capacitor stores energy between two metal plates. So that's where the symbol comes from. So what you need to know about capacitors is they're used to store energy. If you look at their legs, on these ones at least, one leg is longer than the other. The longer leg is actually going to be the positive side, and the shorter one is the negative side. And you'll see on your PCB that it will be marked positive and negative. Or just, I guess this one just says positive, but that's where you'll know to put the positive leg in there. And then once we put our components on, we want to make sure we secure them on. Solder isn't glue. We're using it to make a connection between the traces on the back of the PCB and the actual components. So we want to make sure that's secured on. It also just makes soldering easier.
So we've got one capacitor in there. We're going to go ahead and put the other one, as E said, the longer is the positive. See the plus there? And the other side is the negative. Stick those in there and bend it. And I'm going to go ahead and solder these first before I move on to the ceramic ones. Just so you can see it. Just be a little easier than the chip. Ooh. There we go. The other one. There we go. We'll take our wire cutters, cut off these legs so we have more room to move on to the ceramic capacitors. Now, you'll notice the 3 ceramic capacitors have numbers on them. 24, 223, and 103. Take a look on our board, and here's 223. Go ahead, place that in.
These ones don't have positive or negative legs you have to worry about.
Exactly. And right under, I'm noticing 24. I didn't take 24. And where could 103 be? There it is. So you can see it might have been very, very hard to do the chip last, which I did, but we learned by trial and error.
Which some of us learned the hard way.
That's the whole fun.
That's why we're here.
A little bit more on this one. Want to make sure it's covered completely. That's good. And we'll cut them.
So inductors usually look like this. Because they're a little metal coil, and what they do is they store energy by making this magnetic field, like because of this metal coil. In this case, and actually our inductors, as far as a radio goes, this is what helps us get to particular frequencies. And a really rudimentary radio, actually, if you didn't have like these fancy buttons or a tuning wheel or something like that, the ways in which you would change channels would be by like literally squeezing your metal coil. So that's not the case here. Actually, in the case here, our inductors look like resistors. They look like this. I don't know why. Okay, there you go. But they do.
Now that we've got our capacitors in here, we're gonna go ahead and put the inductors. As E beautifully described, you'll see a 2D drawing here of a coil. That's how we know we've got our inductors and not a resistor. So put that on in there and bend it down. Same with this one. These two look the same, and you can tell by their colors. Right on there. Then we'll take the last inductor, seal another coil there, put it in, and then we'll move on to our only resistor here. It's a 30K, because it'll say right here on the PCB board, but if you had multiple and you want to figure out which resistor is which, there's an application or calculators online where you can plug in these numbers depending on the bands. We've got a 4-band here. Sometimes there's 5, sometimes there's 6. And that will tell you which resistor you have. We'll go ahead and solder now.